Okay, so good morning once again. It's been a while. WebEx, before we start, WebEx, how many of you were not able to attend the WebEx class on Monday? Okay, just an advice. Next time we have a WebEx session, you don't need to download WebEx onto your computer or your device. You can just join from the browser, all right? So every time you click on the link, you have two options, whether you download WebEx or you can join from the browser. You can always join from the browser, that's good enough, okay? My next question, do you know how to access the recording on WebEx? No? Okay, so I'll show you that quickly, very quickly. All right, so as a student, this is what you'll see. So external tools. And the class on Monday, which was on WebEx. You click on completed. All right, this is what we had on Monday, and you can view the recording. Okay, so select this, they'll give you a password. So copy. So before you view, you need to enter the password, and you should be able to go straight into the session. Are we clear on that? Okay, so again, external tools. Monday, click on completed, and this is the session we had on Monday. Last week, Wednesday, because there was an examination that was held here, we had the session on WebEx as well, so the recording is here. That was on the 23rd, okay? Now, I believe by now some students are not able to access Moodle. For some reason, if you are one of those students, please come and see me because we have quiz and tests that's coming. I don't want you to miss out on the test and the quiz. Until you're able to sort out your fees, then we can still work your way around it, okay? Some of you might be hesitant to come to class just because you can't access Moodle, okay? If you're able to pay your school fees in the next few weeks, then you can continue to come to class, and you can always let me know so I can open the quiz or extend the quiz for you. All right, so very quickly on Monday, we had discussed the applications of addition law. So there are three applications. The first one is where you have to rewrite such expressions into either a sine function or a cosine function. So these formulas, in previous years, we usually ask the students to cram these formulas. This year, you're very fortunate because these formulas will be on Moodle. Okay, so it's just a matter of how to use the formula in order to express f of x into r sine x plus theta or f of x equal to r cos x plus theta. On Monday, we discussed that in order for you to change this, all you need to do is find the value for r and the value for theta. And it's important that when you are doing this, your calculator must be in radian mode. All right, so you should be able to change your calculator to radian mode. In addition to that, we also discussed the second application, which is the products of sine and cosine. You might see this as well in your tutorial. This formula here in the box is also given. When you see a product of sine or cosine, you have to apply one of the four equations in order to find the exact value. These values here It won't be given, so you have to cram the exact values. When you're given exact value problems and you come across 0.866, that is equivalent to square root 3 over 2. So the tutorial this week focuses on exact value problems. The third one was sum to product. If you're given expressions such as sine plus sine, sine minus sine, cos plus sine, or cos minus cos, you have to substitute the following equations. And these are the three applications for the addition formula. One thing that we missed out was this one here. This is a very important note. What you should know that there are three types of exact value problems. There are three types of exact value problems. The first type is sine 15. Here you have to choose angles such as 30, 45, or 60 degrees. All right, 30, 45, and 60 degrees, and then you use the addition formula. The second one is the product of sine and cosine, and the last one is the sum of sine and cosine. So these are the three types of questions that you will come across when it comes to exact value problems. It's important to note that different methods are applied. So whatever method you apply to number 1, you won't be able to apply that to 2 and 3, because all this will depend on the formula. Okay? So exact value problems, these are very important. These values, root 3 over 2, root 2 over 2, square root 3 over 3, and square root of 3. Everybody knows 0.5. That's why it's not here. So 0.5, that is equal to 1 over 2. I've only just put these 4 values. Okay, so whatever we discussed, this is unit 12, all right? This is unit 12, which is application of addition formula. We are going to skip unit 13. So unit 13, you can always read through and go through the notes. It focuses on inverse trig functions, okay? So today we'll jump straight to unit 14, which is trigonometric equation. I believe you have seen this before in high school. So here are a few key ideas that you should keep in mind when it comes to solving. The first one is very, very important. When solving trigonometric equations, you have to make the trig function the subject. Do you understand what this means? Make the trig function the subject. Here. All right, the trig function must be the subject. So cos, sine, or tangent is equal to a value. In some cases, you have equations such as this. The same idea applies. No matter the type of problem, the first step is for you to ensure that you make the trig function the subject. So first step, try and make the trig function the subject, and then the next one, you pick the quadrant where the solution lies. So let's take, for instance, if I have sine of theta, sine theta is equal to negative half. All right, sine theta is equal to negative half. First, the trig function is already the subject, so now you can solve. Now, the value or the solution is a negative value. Okay, so you have to identify the quadrant where sine is negative. Is that clear? You have to identify the quadrant where sine is negative. Now, in high school, you must have learned A, S, T, and C. What that means is in the first quadrant, all the trig functions are positive. So sine, cos, and tangent. Let me try and zoom in. Okay, can you see that now? So in the first quadrant, sine, cosine, and tangent are all positive. In the second quadrant, only sine is positive, which means cosine and tangent are negative. In the third quadrant, what is positive? T represents tangent. So tangent is positive in the third quadrant, which means sine and cosine are negative. And in the fourth quadrant, C represents cosine. So cosine is positive in the fourth quadrant, and which makes sine and tangent negative. So if we go back and ask yourself, in which two quadrant is sine negative? Quadrant number 3 and 4, all right? Quadrant number 3 and 4, so that means your solution will lie in quadrant 3 and 4. The other thing is, another point, draw a reference angle y in the quadrant marked. The fourth point is, in order for you to find the value of y, you use the inverse trig function in the calculator. So when you solve, when it's time for you to solve for theta, it'll be theta is equal to sine inverse, okay? Sine inverse. Every time you solve for the solution, you will always take the positive value. Okay, so step number 1, make the trig function the subject. Step 2, identify the quadrant where the solution lies. Step 3 is mark the quadrant. And 4, you solve for theta. When you solve for theta, if it's negative, you have to change that to positive. All right, so whenever it comes to calculating theta, you always take the positive value, which means if it's positive, it will remain as positive. So every time you find theta, you take the positive value. So let's take, for instance, let's calculate what is sine inverse of half. 30 degrees, 30 degrees. So our solution lies in the third and fourth quadrant. When we solve, theta is equal to 30 degrees. In the third quadrant, it's 180 plus 30. So what is 180 plus 30? 210. That's the first solution. Your answer is not 30 degrees. Your answer is 210. And the second quadrant is, and the second solution is in the fourth quadrant. So 360 minus 30. All right? Now, the other thing that you should note is when solving, and if you notice that the restriction here, the interval, if the interval is given in radians, that means you have to convert your angles to radians. Okay, I hope you haven't forgotten that. So if this is 210 degrees and this is 330 degrees, we have to change this to radians. We won't accept decimal values unless if this is 0 to 360, then we will accept the degree values. If it's in radian values, then we expect you to write your solution in degree values. In radian values. And then you come across values such as this, where you have decimal values. If you come across decimal values, then 180 is equal to pi, and you're going to use pi as 3.14. Is that clear? All right. If your question is given in decimal values, like question number 7, you follow the same steps, but in place of 180, you're going to use pi equal to 3.14. Okay, a lot of information. Let's try a few questions now. First one. Solve for sine x is equal to the square root of 2 divided by 2. Make sure you have your calculator with you. Bring out your calculator and we are going to do this together. If you want to solve, go ahead. So first up, is that okay? In the back, all set? Thank you. All right, so it's important to check, excuse me, the trig function is already the subject, so you can go ahead and solve. Now, first things first, draw the quadrant. This is 1, 2, 3, and 4. Sign is positive. So in which two quadrant is sign positive? The first and second quadrant. So next thing is you have to draw a reference point, which is y. That means your value will be in the first and the second quadrant. Now let's solve. Sin y, this value of y, is equal to the positive value of square root 2 over 2. Y is equal to the sine inverse of square root 2 divided by 2. Calculate. Sine inverse root 2 divided by 2. What do you get? 45 degrees. So y is equal to 45 degrees. So this angle is 45 degrees, and this is also 45 degrees. Let's go back to our this one right here. First quadrant, whatever value that you get, theta. All right, so first quadrant, x is equal to 30 degrees. And in the second quadrant, it is x is equal to 180 minus 30 degrees. Sorry, 45, not 30, 45. 45 and 45. Scratch that. Quadrant 1, x is equal to 45 degrees. Quadrant 2, x is equal to 180 minus 45 degrees. Now, the restriction says it should be between 0 and 2 pi. So that means I have to change this. 45 degrees to radians, 45 over 180. That's 1 over 4. So 45 is pi over 4. In the second quadrant, we have x is equal to 135 degrees. So to change that 135 over 180, that's 3/4. So that is 3 pi over 4. So we can say that therefore the solution x is equal to pi over 4 and 3 pi over 4. So step number 1 is to ensure that the trig function is the subject. Okay, for now, sine is the subject, so we can start solving. The second one is to check where does the solution lie. Since the solution is positive, our solution is in the first and the second quadrant. Then you draw the quadrant and label them Y. The second, this is the most important one. Whenever you calculate, you always take the positive value. Is that clear? So if this was negative, you change it to positive. If it's positive, leave it as a positive value. All right, so sine inverse of root 2 divided by 2. Okay, let me show you something. How many of you are getting 90 degrees? Whenever you calculate, use division. Is that clear? All right, if you're getting 90 degrees, if you're wondering, how did I get 45? One, when you are calculating, you won't use the fraction value, you have to use divide. That is 45 degrees. Every time you calculate, keep that in mind. Every time you calculate and you have a fraction, use division. Are we clear? Okay, so that's why our answer is 45 degrees. First quadrant, whatever value you get in the first quadrant, it's the same. In the second quadrant, it is 180 minus 45. And the reason why we change that to radiant is because our interval is in radians. So that means the extra step is change 45 degrees to radians. Again, 45 fraction 180, that's 1 over 4, so pi over 4, and 135 over 180, the fraction is 3/4, so 3 pi over 4. And in the end, you have to conclude that therefore, x is equal to pi over 4 and 3 pi over 4. Are we clear? Yes? All right, so we'll move on to the next question. Let's see how far you can go with the next question. Cos x is equal to negative root 3 over 2. Cos x is equal to negative root 3 over 2. Right, so cos function, the solution is negative. So cos inverse is equal to square root 3 over 2, in which 2 quadrant is cos negative 2 and 3. I label this as y, and I'll label this as y. So now we calculate cos y is equal to the positive value of square root 3 divided by 2. Y is equal to cos inverse of the positive value of square root 3 divided by 2. What do you get? 30 degrees. All right, 30 degrees. The solution lies in the second. Solution lies in the second quadrant. and the third quadrant. So x is equal to 180 minus y, so 180 minus 30 degrees. And in the third quadrant, it's 180 plus y, so 180 plus 30 degrees. I want you to carry on from here and change your values to radians. Right, so therefore, in the second quadrant, you get 150 degrees. If you change that to radian, that's 5 pi over 6. In the third quadrant, it's 210. Change that to radians, it's 7 pi over 6. So therefore, x is equal to 5 pi over 6 and 7 pi over 6. This is the basics. All right, this is the basics. Once you get a hold of this, then we can move on to the complicated questions. Let's try one more of the basic question. Tangent x is equal to the square root of 3. Tangent x is equal to square root 3. Now I'll give you about 5 minutes or 3 minutes to answer this question. See how far you can go. Right, so tangent x is equal to the square root of 3. The solution for tangent is positive. So the two quadrants where the solution will lie is in the first and the third quadrant. Again, this is very, very important. Every time you solve for y, you take the positive value. So tangent y, y is equal to tangent inverse of square root of 3. What is the value for y? 60 degrees. So in the first quadrant, x is equal to 60 degrees, and in the third quadrant, x is equal to 180 plus 60 degrees. Change this to radians. This is pi over 3. And 240 degrees, change this to radians, is 4 pi over 3. So therefore, x is equal to pi over 3 and 4 pi over 3. Let's look at question number 9. There was one point that I forgot, the last one. Please do note. Decimal values, when you come across decimal values, your calculator must be in radian mode. This is another one. When sine or the cosine is equal to 0, 1, or -1, then instead of solving, the quickest way is to sketch the graph of a function. Is that clear? All right. So this point will come in very handy for the next question. Let's look at question number 9. Question 9 is 2 cos x sine x minus cos x is equal to 0. Remember the first note, make the trig function the subject. All right? So for this type of problem, it's important that you have to make the trig function the subject. So let's go to the question once again. We have 2 cos x sine x minus cos x is equal to 0. One function minus another function. If you look at these two, is there anything common? Cos. So if I take out cos, what's left inside the bracket? 2 sine x, what? Minus 1 is equal to 0. Are we clear? You start off with this. You'll notice that cos x is a common factor. You take that out, now you have 2 factors. One is cos x, the second factor is 2 sine x minus 1. So what this simply means is cos x is equal to 0 and 2 sine x minus 1 is equal to 0. All right? Cos x equal to 0. And the second one is 2 sine x minus 1 is equal to 0. So the basic steps that I discussed with you, is what you're going to do for the first one and also for the second. So let's go through this. If the trig function is equal to 0, you don't need to solve, just draw. Where is cos 0? 0 and 2 pi. Yeah? Cos is 0 at 0 and 2 pi, or 360. So that means your answer here for the first one, x is 0 and x is equal to 2 pi. This is the quickest way. This is the quickest way to solve. Whereas for the second one, we have to make sine x the subject. If I make sine x the subject, I move the 1 and the 2. Right? So 2 sine x is equal to 1, and sine x is equal to half. 2 sine x minus 1 equal to 0. I take the negative 1 to the opposite side, it becomes positive 1. Since this is multiplied, I have to divide, so sine x is equal to half. Then, which 2 quadrant is sine positive? First and second. So first and second, y and y. So y is equal to sine inverse of positive 1 over 2. Solve this. What is the value for y? 30 degrees. In the first quadrant, x is equal to 30 degrees. In the second quadrant, x is equal to 180 minus 30. So when we solve 2 sine x minus 1 equals 0, our solution is 30 degrees and 150 degrees. When you solve for cos x equal to 0, our solution is 0 and 2 pi. So let's change this. What is 30 degrees? Pi over 6. What is 150? 5 pi over 6. So, therefore, x is now equal to 0, 30 degrees, 150, and 2 pi. So as I've mentioned earlier, the first 3 questions that we did were the basic questions, okay? So we started off with 2 cos x sine x. We factorized, and we equated each factor to 0, okay? We equate each factor to 0, so cos x is 0, and 2 sine x minus 1 is equal to 0. So you have to solve them separately. Now, I'll take you back to the note that I mentioned earlier. This note right here. So when the sine or cosine function is equal to 0, 1, or negative 1, to find the solution is to simply sketch the graph. just a small graph. You don't have to draw the big graph that we taught you a few weeks ago. Okay, so zero is 90 degrees. Sorry. Can you make this correction, please? This one here. This is 1. It's supposed to be 0. 0 is here and here. This is 0. So this is 90 degrees. Pi over 2. And this is 270. 3 pi over 2. If it was cos x equal to 1, then the answer would have been 0 and 2 pi. Please make that correction. If cos x is equal to 1, then 0 and 2 pi. Our answer here is 90 and 270. So x is equal to 30, 90, 150, and 270. Last one. Three sine squared x minus 2 sine x is equal to 1. 3 sine squared x minus 2 sine x is equal to 1. Right, so the problem is 3 sine squared x minus 2x is equal to 1. Pay attention. You take the 1 to the opposite side, so everything is equal to 0. So now we have 3 sine squared minus 2 sine minus 1. The hint is this. Try and factorize 3x squared minus 2x minus 1. What do you get when you factorize 3x squared minus 2x minus 1? Three x plus 1 and x minus 1? If you still don't know how to factorize, please come and see me after lecture. This is a big problem. All right, so what I've done here is in place of sine x, I put x. In place of sine x, I put x. So 2 sine x is 2x. 3 sine squared is 3x squared. When you factorize this, it's the same as 3 sine x plus 1 and sine x minus 1 is equal to 0. And since each factor is equal to 0, you'll have to solve them separately. 3 sine x plus 1 equals 0. And the second one is sine x minus 1 is equal to 0. All right, so I'll leave this for you to try later. Okay, I hope you get an idea of the basic steps for solving trigonometric functions. That's what we started the class with today. The ideas that we discussed are as follows. Number one, when solving trigonometric equations, make the trig function the subject. Second point, you place a tick in the quadrant where the solution lies. And when it comes to solving, if it's in the first quadrant, the value is basically equal to theta. In the second quadrant, 180 minus theta. Third quadrant, 180 plus theta. In the fourth quadrant, 360 minus theta. When solving this as well, your calculator must be in in degree mode. If the solution is given as 0 to 2 pi, that means you have to change your answers from degree to radians. But if you come across questions where you have solutions that are in radians or in decimal values, that means you follow the same steps, but your calculator must be in radian mode. In addition to that, when you come across sine and cosine that's equal to 0, 1, or negative 1, you don't need to solve, you just make a quick sketch of the graph, and you should be able to locate the solution on the graph. This is the last topic for Unit 3. All right, this is the last topic, so when we meet next week, we're going to move on to complex numbers. As I mentioned in the first lecture, the moment we start doing complex numbers, that's an indication that we're coming to the end of the semester. Test 1, if you haven't collected, please come and collect. Special test, we're still receiving applications. We have yet to confirm the date. And for anyone who scored less than 10% in their test, please come and see me. All right, we'll discuss options for you, and that is to start having revision classes. All right, so please come and see me so we can discuss revision classes. I'm happy with the marks for test 1. Pass rate is sitting exactly at 50%. Exactly at 50%. It's a plus for me compared to last year. It was less than 50. Okay, so that means something that we're doing is working. For those of you that have failed, please come and see me because we're trying to arrange extra classes, especially for revision for test 2 and the final exam. Thank you so much for coming today. Attendance, who has the attendance paper? Has everyone filled in the attendance? No? Okay, David, because you were holding on to that, you'll stand at the door and people will write down their name. Thank you for coming. If you've put your name down on the paper, you may leave. If you haven't, write your name on the paper.